For nearly 50 years, the most respected astronomers in the world were convinced there was a hidden planet between Mercury and the Sun. They named it, mapped its predicted orbit, and some claimed to have seen it transit the solar disk. It did not exist. But the reason scientists believed it did, and what finally killed the idea, is one of the most important stories in the history of physics. The story begins with a real anomaly. Mercury's orbit around the Sun does not behave the way Newtonian mechanics predicts. The point in Mercury's orbit closest to the Sun, called the perihelion, shifts slightly with each orbit. It precesses, rotating forward by a total of 574 arcseconds per century. Most of that can be explained by the gravitational pull of other planets. But after accounting for every known planet, there remained an unexplained residual of 43 arcseconds per century. In the 1800s, that was a significant discrepancy. Something had to be causing it. The French mathematician Urbain Le Verrier is the reason this story exists. In 1846, Le Verrier had predicted the existence and location of Neptune purely from anomalies in Uranus's orbit. Neptune was found within 1 degree of his prediction. It was one of the greatest triumphs of Newtonian mechanics in history. So when Le Verrier turned his attention to Mercury's orbital anomaly in 1859 and proposed that an undiscovered planet between Mercury and the Sun was causing the discrepancy, the scientific world took him seriously. Le Verrier named the proposed planet Vulcan after the Roman god of fire. He calculated where it should orbit, closer to the Sun than Mercury, completing a full orbit in about 19.7 days, invisible from Earth because it would always be close to the blinding solar disk. Then came the apparent confirmation. In the same year, 1859, a French amateur astronomer named Edmond Modeste Lescarbault wrote to Le Verrier claiming he had observed a small dark disk crossing the Sun, a transit, that lasted about 1 hour and 17 minutes. Le Verrier visited Lescarbault personally, was convinced by the man's data and instruments, and announced to the French Academy of Sciences that Vulcan had been observed. The scientific press treated it as a discovery. Over the following decades, dozens of additional sightings were reported, almost always during total solar eclipses when objects near the Sun become briefly visible, or during sunspot observations. Each time, observers claimed to see points of light or disks near the Sun that didn't match any known object. None could be consistently reproduced or coordinated between multiple observers at the same time. Attempts to predict Vulcan's position from Le Verrier's calculations and observe it during solar transits, when it should have been visible as a dark dot crossing the Sun, consistently failed. The most embarrassing moment came during the 1878 total solar eclipse in the United States, when 2 experienced observers, James Craig Watson and Lewis Swift, both claimed to have seen Vulcan from different locations, but their descriptions and calculated positions did not agree with each other. The death of Vulcan came in November 1915. Albert Einstein published his general theory of relativity. In that theory, the Sun's mass curves spacetime, and objects moving through curved spacetime near the Sun follow paths slightly different from those predicted by Newtonian gravity. When Einstein calculated the expected perihelion precession of Mercury's orbit using general relativity, he got exactly 43 arcseconds per century, precisely the unexplained residual that had motivated the Vulcan hypothesis for nearly 60 years. No planet was needed. The anomaly was not caused by a missing body. It was caused by the geometry of spacetime itself. Mercury's orbit is the oldest observational confirmation of general relativity. Einstein reportedly said that seeing the perihelion result match the observation gave him heart palpitations. It was not just the prediction, it was the obliteration of a decades-long mystery with a single equation. Vulcan was never real, but the search for it was not wasted. It was a rational response to a genuine anomaly using the best physics available. And the anomaly it tried to explain led directly to one of the deepest insights in the history of science. Follow for more on the scientific dead ends that led to the greatest discoveries. And tell me, if general relativity had not explained Mercury's orbit, what other explanation do you think physicists would have reached for next?